In order to discuss delusion in Cauchy completeness, I'll begin with digit length in rational numbers. Rational numbers are numbers p over q for any two natural numbers p and q. Q is larger than 0. The decimal expansion of a rational number either terminates after a finite number of digits or begins to repeat the same finite sequence of digits. Any repeating or terminating decimal sequence represents a rational number. And this statement holds true in any other base number system. A rational number within the unit interval can be expressed as a point a b bar. A is a leading sequence of finite number of digits, and b bar is a repeating sequence of a finite number of digits. A rational number which terminates after a finite number of digits can be considered as a special case of a point a b bar where b is 0. And then, what will be the number of iterations of b in point a b bar, which leads to the digit length in rational numbers? From the following proposition that 0.999 ... which is 0.9 bar equals 1, we can start examining the digit length of rational numbers. Let x equals 1 over 9, which is 0.111 ... which is 0.1 bar. As 9x is 1, then we can prove 0.9 bar equals 1. And we can prove the digit length, or the number of iterations of 9 in 0.9 bar is uncountable. We have 1 equals 0.99 ... which is 1 minus 1 over 10 powered by infinity. 1 over 10 powered by infinity should be 0 in order for 1 equals 1 minus 1 over 10 powered by infinity. Please note that infinity, which is the digit length, is not from n in natural numbers, but from the number of iterations of 9 in 0.9 bar, which is to make the equality in 1 equals 0.999 ... If the digit length infinity is Aleph null, then 1 over 10 powered by infinity is 1 over 10 powered by Aleph null. And we can show 1 over 10 powered by Aleph null equals 1 over 2 powered by Aleph null. It will be shown that 2 powered by Aleph null equals Aleph null in video 11. The proof in video 11 is independent of Cauchy completeness or the concept of convergence and limit. And 1 over 2 powered by Aleph null equals 1 over Aleph null, which is iota. Thus, 1 over 10 powered by Aleph null is larger than 0. However, 1 over 10 powered by infinity should be 0 in order for 1 equals 1 minus 1 over 10 powered by infinity. Therefore, infinity, which is the digit length or the number of iterations of 9 in 0.9 bar, should be larger than Aleph null, that is, uncountable. Cauchy sequence x of n is for n in natural numbers. Therefore, 0.999 ... cannot be expressed by Cauchy sequence even though it can be expressed by notation as 0.9 bar. If infinity in 1 over 10 powered by infinity is c, then 1 over 10 powered by infinity equals 0. Thus, c can be the digit length or number of iterations of 9 in 0.9 bar. Please note that C is a concept that creates something from nothing and annihilates something into nothing, as discussed in video 5. And we can show the number of iterations of B in point A, B bar expressing a rational number is uncountable. You can stop the video and follow the proof yourself. And you can see that the number of iterations of the terminal repeat sequence B is larger than RF null, that is uncountable. Except for those rational numbers whose terminal repeat sequence B is 0, the digit length in rational numbers is uncountable. Even though the digit length in rational number is larger than RF null, rational numbers can be written in digit representation by notation like 1 over 9 equals 0.111 dot 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 equals 0.1 bar, 1 over 10 equals 0.1000 dot 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 equals 0.10 bar equals 0.1. It is important to note that the number of iterations written by notation like dot dot dot, 1 bar, and 0 bar is uncountable. The meaning of notation 0.333 dot 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 and 0.3 bar is that 3 repeats itself infinitely. However, the notation does not specify the size of infinity as countably infinite. 1 over 3 equals 0.333 dot 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 equals 0.3 bar, but is not equal to 3 multiplied by sigma 1 over 10 powered by n, which is only close to 1 over 3. The number of iterations of 3 in the notation 0.333 dot 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 or 0.3 bar is different from infinity or the symbol dot 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 in the formula below. This distinction is critical because of the inability of the symbol dot 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 or the infinity symbol to distinguish different sizes of infinity has led to many mistakes and confusion. Rational numbers with a terminal repeat sequence cannot be a Cauchy sequence because the number of iterations of B in point A, B bar expressing a rational number is uncountable when Cauchy sequence x sub n is for n in natural numbers. It is akin to the fact that 0.02 bar in base 3 number system is within the interval but not as the endpoint in Cantor set. Note it applies in other number systems like base 2 or base 3 number system. Only the rational numbers whose digit terminates with the trailing zeros can be a Cauchy sequence. And there is a proof in the textbook that 0.999 dot 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 equals 1 by employing Cauchy sequence. However, the proof is flawed. The proof is like this. If A sub n and B sub n are two Cauchy sequences, then they are equal as real numbers if the sequence a sub n minus b sub n has a limit 0. Consider a sub n equals 1, 1.0, 1.00 dot dot dot, and b sub n equals 0, 0.9, 0.99 dot dot dot, then a sub n minus b sub n equals 1, 0.1, 0.01 dot dot dot. The nth term of the sequence is 1 over 10 powered by n, and limit 1 over 10 powered by n equals 0. Thus, a sub n and b sub n are equal, so that 1 equals 0.999 dot dot dot. However, this proof is flawed. The proof depends on the assumption that limit 1 over 10 powered by n equals 0. However, suppose limit 1 over 10 powered by n equals 0. In video 2, it was shown that 1 over 3 powered by n is larger than 0 for all n in natural numbers. Thus, 1 over 3 powered by 3n is larger than 0 for all natural numbers. Assume limit 1 over 3 powered by 3n equals 0. If we were not to doublespeak, limit 1 over 3 powered by 3n equals 0 dictates 1 over 3 powered by 3n equals 0 for some n in natural numbers, because n is for n in natural numbers in limit 1 over 3 powered by 3n. Thus, the assumption limit 1 over 3 powered by 3n equals 0 contradicts 1 over 3 powered by 3n is larger than 0 for all natural numbers. Thus, limit 1 over 3 powered by 3n is larger than 0. Thus, limit 1 over 10 powered by n is larger than 0. Thus, the assumption limit 1 over 10 powered by n equals 0 is flawed. Thus, the proof is flawed. In mathematics, the fact that the answer is correct does not mean the proof itself is correct. As in the case of the proof that Lebesgue measure of natural numbers is 0 by the concept of convergence and limit is flawed, as discussed in video 4. The illusion that Cauchy sequence prove the true proposition 0.999 equals 1 is due to the misassumption that limit 1 over 10 powered by n equals 0, which depended on the concept of convergence and limit, thus is a circular logic based on wrong assumption. That Cauchy sequence can prove the proposition 0.999 equals 1 gives an illusion that Cauchy completeness and the concept of convergence and limit are correct. However, even though 0.999 equals 1 is true, the proof by Cauchy sequence is an illusion because Cauchy sequence x sub n is for n in natural numbers, but the number of iterations of 9 in 0.999 is uncountable. This infinity symbol does not differentially specify the cardinality of infinity between Aleph null and infinity larger than Aleph null. This inability to differentially specify the cardinality of infinity by the symbol is the origin of this illusion. Please send critical comments to this address. Thank you very much.